Okay, welcome back to part two of our measures of central tendency video and its relationship to the normal distribution curve. So again, if you're following in a textbook, Intro to Biostats by Larry Winter, page 35 to 40 is related to much of the content here. So we're going to still focus now on the median, the mode. We just did the mean. So the median, many of you all are already familiar with the median. It's one of the central measures of tendency. And if you were to rank the data and pick the middle value, you can get the median. The median is the middle value for a given set of data. So in the case of 4, 2, 3, 5, 7, and 1, how would we get the media? Well, we would determine the middle value. So in order to determine the middle value of 3, we would have had to have reordered the data. First, we would need to order, sort, and rank the data from lowest to highest. So you have that data, we reordered it, and we determined that 3 was the middle value. So sometimes you have a situation with a tie. In this case, the middle value, 3, has 3 numbers below it, 3 numbers above it. It's an odd number in terms of the total number of data. N equals 7, so the sample size was 7. It's 7 numbers, and it makes it very easy to get the median because you can find out the middle value. So the fourth number is 3 away from the top and 3 away from the bottom. What happens though when you have a number, if we add in an extra number and we end up with something like a sample size of 8? How do we determine the median here? Is it 2? Is it 3? What do we do? Pretty easy stuff. We just use the arithmetic mean of these two numbers. So 2 and 3 divided by 2. So 5 divided by 2 gives us 2.5, which represents the median. Very simple. If you want to use Stata or Excel to get the median, in Stata, we would type in sum, var1, varx, and detail. That detail will give us the 50th percentile, which is the median. When I say varx, you can do multiple variables at the same time. You only have to do one, but you can do multiple variables at the same time. So varx is optional for the other variables. And the output that it will give us a lot, but again, the 50th percentile is what we'll look at to see the median value. In Excel, you just highlight the data after you put in the median command. So equals median, and then you highlight the data. Very simple. So we'll come back to the mode here in a second. We'll do a few examples real quick in Stata. In Stata, I'll open up one of our recent files, like the Big County Health data set, and maybe we're interested in getting the median for life expectancy for the United States. So what's the middle value among all the counties when you rank them from lowest to highest? So if I were to type in the command, I don't know if it'll let me zoom in anymore. I can do full screen. But if I was to type in the command sum life expect 14, that's not going to give me enough. That's only going to give me the number of observations, the mean, and the standard deviation, minimum value, and maximum. I need the middle value. How am I going to get the middle value? So I would type in sum life expect 14, and I use a comma and say I need a more detailed look. Detail, and then when I do that, it gives me a 50th percentile right here, and that 50th percentile is 77.93. Not too different than the mean of 77.75 from our previous command or in the detailed version. And when we do sum detail, we also get all these percentiles. We get the 25th percentile, the 75th percentile. We see the S, the variance, S squared, standard deviation, 2.38. So if you do 2.38 times 2.38, you would get that number right there, the variance. So we get a lot of information, how skewed the data are, all that stuff. So we'll come back to that later. View, I'm going to go back to what we've got here before. So we should still be recording. All right. Next, we're going to go to Microsoft Excel. So there was our data set before. We had 3, 4, 2, 5. We can add on to that. So if I want the median, I just type in equals median. I'm going to highlight this set of data here. Shouldn't be a plus sign though. I may have hit a button by mistake. Yeah, that didn't work. Equals median. Alright, see the parentheses? Now I'm going to highlight it. I must have hit a plus key earlier by mistake. So now median, highlighted data, J2 to J9, enter, and the median number is 4. So if we were to rank these from lowest to highest, delete that, sort. If I were to sort these from lowest to highest, that's our middle value. Let's see, it's middle value is 4, middle value is 4, 4 divided by 4, or 4 plus 4 divided by 2, it's 8 over 2. We end up with a median of 4. Very easy. Okay, returning back to our PowerPoint. So we should be able to get the median in Stata and Excel using those simple commands. The next one we're going to talk about is the mode. And the mode is the most frequently observed value in a data set. And sometimes, though, there are more than one modes in your data set. Sometimes there's a major mode and then what we call kind of minor modes. So if you had a data set like 1, 2, 1, 1, 1, 1, 4, 5, 1, 1, 4, 2, 1, 5, that may not necessarily be your middle value, like your median or your average, but 1 is the most frequently observed data point, so the mode would be 1. As I said, sometimes there's more than one mode. So in this case, the mode here, when they bend the data get put in bins. Essentially, they might have 30 or 40 bins that they put the data and say, well, we're going to take all the numbers between 75.1 and 75.5 or 76 and stick them all in this bin, and any decimal for accounting will show up in this bin. And this bin might be something like 76 to 77. I don't know what that is, but that might be that particular bin. So data in that bin on a stat program are the most frequently observed numbers, and this one's pretty close, but it looks like this particular bin, whatever that number is, the average of this bin is what the program would tell you is the mode. Now, sometimes you've got things like this, like, well, here's this particular bin for numbers that fit between 8 and 8.49 or 8.5. This particular bin for this variable body length would be what you would call the mode. And it's the biggest mode, so we might call it the major mode, but for whatever reason, there's some right here as well that are numerous. And sometimes you'll see this in like biological studies on feeding, where once they get above 5 on this body length, some minnow or some fish really likes to eat whatever these organisms are, so they all become lunch. And then they get too big, they put up a good fight, or they sting them or something, so they leave these guys alone and then they die by old age. So you might have a bimodal system or bimodal set of data, and they would call us the major mode and the minor mode. Sometimes there's more than 2 modes. It's beyond bimodal. In this case, there are 3 modes. We would call this multimodal, and again, this is the biggest one, so they might call that the major mode, the tall one, and the other ones are minor modes. And going again, these are in bins. They're not every single thing measured at this exact body mass. Maybe in this case they were put, but there's bins on continuous data. They kind of put them in the groups. So in Stata, if you're trying to get the mode, that should say mode, getting modes in Stata and Excel, it's a little more difficult to get the mode because it depends upon your objective, and it's a little more complicated than just the most frequently observed value. In Excel, it will give us the major mode, and that's pretty much all it will give us. If it's bimodal or multimodal, you don't know that by looking at that. And if there are any ties, again, Excel will use the highest mode. So if you've got 4 being the most frequently observed observation and it's bimodal, and then the number 8 is also the most frequently observed observation, and they're both observed an equal number of times, Excel will choose the highest value by using the command mode. So if I were to go to Excel and do the mode on this set we got here, equals mode, we get 4. So that 4 is the most frequently observed number. Now if I were to put in a number 7, 4 occurs twice, 7 occurs twice, equals mode. Same set of data. It's going to pick 7. Let's see. I guess it said it picked 4. Let's see. Did I go far enough down? Huh. Well, I guess it chose 4 because it was maybe in the center of the data. I don't know. I'll give it 7 again and see what happens. Equals mode. Different rules that are used for determining the mode vary. So now it chose 7. All right. I'm going to pick 4 now, there, so now it chose 4 again. If I do 3, 3, it's actually, in this case, there's 3 3s, 3 4s, 3 7s. It's choosing the lowest number to be its mode when there's a situation of a tie. If I pick the big number here, put a 7 in there, equals mode, it'll pick the 7. It's the most frequently observed number. So when there's ties on the mode, it will choose the lowest number in Excel. So I got those backwards on that. But needless to say, the mode, it's not used a whole heck of a lot in a lot of the statistics, except for maybe when people are looking at curves. So the next area we're going to be talking about, we're going to finish up. We're in part 2, but we'll finish that up, and we'll have a part 3 that will focus a lot more on the normal distribution. So normal distribution and how that relates to the measures of central tendency.